Flavins are an interesting class of chemicals, and off of their base structure, which contains a couple of benzene rings, some cyclohexane rings, and that can be formed into sort of phenols, and that becomes polyphenols and stuff. It can have loads of different stuff in and off of its general base structure to create even more different general base structures. You've got flavonoids, flavones, flavanols, things. You've even got like things like isoflavonoids, isoflavones, and all that sort of stuff. Such a wide range of chemicals, and they are incredibly interesting, and they are the sort of stuff that is contained inside of real food. The phytochemicals, the random stuff that plants produce that are good for you, and not some like plant defense chemicals and stuff. They're actually good for you. They're not just some random things that these apples and spinaches make to try harm the things that eat it. It's actually the good stuff. Some example of these flavonoids and etc, you're going to have things like hesperidine, apigenin, catechine. You're then going to have loads of other chemicals that are slightly far away from flavonoids that are still phytochemicals but have like different base structures like coumarins and all that sort of stuff. But what are these flavonoids and what is their purpose inside of the body other than to be some wishy-washy cool chemical names? These flavonoids and these flavones, I'm going to call them flavonoids because it rolls off the tongue better, is that they are antioxidants. And antioxidants are chemicals that I haven't talked about much before, and something that I've never really understood before until I did some research on them. And I knew that there were things inside of the diets that we ate and the foods that we ate that were antioxidant. I knew that vitamin C and vitamin E were antioxidants, and I knew that selenium was an antioxidant, but I didn't know exactly what that meant. I didn't know the exact mechanisms of how these things dealt with what they deal with to actually help the body. But now I do understand how these antioxidants work, and I understand a lot of other things about flavonoids and stuff that I actually wanted to share with you. Now, these chemicals that are part of real food, your whole foods, your fruits, your berries, your grapes, your grains, and all that sort of stuff, are destroyed by processing methods because they are quite fragile chemically. And these antioxidants also have a lot of other beneficial and good properties as well. They're anti-cancer, anti-inflammatory, and that is due to the fact that they scavenge and disarm free radicals. Free radicals, I've gone through the definition a couple of times before, and it won't hurt to do it again. It are these things that have unpaired electrons. Electrons are seen as stable, or they are stable, when they are paired inside of an electron orbital, electron subshells. I'm not going to go into the whole details of them, but if you imagine a period on the periodic table, there are different principal energy levels as you go down a row of the periodic table, and then inside of these rows you have different, and I suppose no one really knows why these electrons want to be paired so badly and why that makes them so much more stable inside of our bodies. Especially, they just want to be paired, and that is what is the main thing to consider. And they will go at a great cost to pair themselves. They will steal things from your cells to pair themselves, and that is bad because that will make you the things inside of your cells free radicals, and they'll just try steal things. It essentially becomes a bit of a chain reaction, I suppose, and that can cause mutagenic side effects, cancer side effects, and loads of bad stuff. Oxidative stress is the cause of free radicals, the primary cause, and oxidative stress causes your cells to die and causes you to age. The less free radicals you have inside of your body, the less you will age. Things like smoking and alcohol produce a lot of free radicals, and hence they cause you to age much more quicker than if you did not do those activities. But since learning about what this stuff does, I wanted to go through the mechanisms of action of how these flavonoids actually work. Now, you'll see some of the phenoxyl groups, which are the benzene rings with the little 6-membered rings with the 3 double bonds inside of them, and they have an OH group attached to them in some places. Sometimes these flavonoids will have 2 hydroxyl groups attached to the phenyl rings, and that is how these flavonoids are able to start the mechanism of action. If you can imagine 2 OH groups on these flavonoids on adjacent carbons, meaning they are next to each other, when these chemicals are floating around your body, they're looking for free radicals like it's some kind of detective TV show or whatever, and they come across one. They come across this highly reactive thing with an unpaired electron, and what will happen to this OH bond is it will split heterolytically. Hetero meaning same, and that means that the oxygen on the flavonoid molecule becomes a free radical itself and only has 1 electron on that oxygen, and the hydrogen free radical will then disarm the free radical that was actually damaging and harming the body. And then the other OH group will do exactly the same thing to another free radical elsewhere, and then there is 2 oxygen free radicals. Now, 2 oxygen free radicals, that can essentially make a pair. If there's 2 free radicals on a molecule, the molecule will figure out ways to rearrange itself and rearrange its electrons to make sure that it's stable, because these things are highly reactive and really, really, really want to be paired, and so it will go at a great cost to do it. Thankfully, these flavonoids, when the OH groups are in these 2 positions, when they're next to each other, and what will happen is one of the bonds, only one in the carbon-carbon double bond inside of the ring, will break, and 1 electron each will go to each of the oxygens. That pairs the electron up and makes it a carbon-oxygen double bond for both of them. That disarms the free radicals, and the flavonoid has a special way of being able to rearrange itself to also become a stable moiety. That is very interesting, and I'm sure even if the OH groups are stationed at different points on the molecule, I guess, is smart enough to figure itself out with electron transfers and proton transfers and loads of different stuff. Double bond switching, tautomerization. And there is another mechanism that I found which contains a non-phenoxyl hydroxyl group. If you imagine the molecule, I think it's flavin-3-ol, where the hydroxyl group is attached to the cyclohexane ring, which has no sort of benzene rings around it. I think there's only 2 double bonds in that ring. What will happen is that OH bond will split heterolytically again, the hydrogen will disarm 1 free radical, and the oxygen will become another free radical. The alkene and the oxygen radical will tautomerize and become a carbon-oxygen double bond and a carbon radical. What this carbon radical can do is it can disarm the free radicals itself. All another free radical has to do is to come along and disarm itself, and then there becomes a pair. Because these free radicals are reactive, they will, make a nice little journey, have a nice little adventure, and find some kind of carbon radical to bond with, which can disarm itself and the carbon radical that was formed from the flavonoid. Unfortunately, this is probably the lesser useful mechanism, because that means that flavonoid antioxidant is now completely rendered useless and will probably have to be metabolized or excreted in some way, shape or form. But with the carbon-oxygen double bonds where 2 of them are produced, it can probably be reduced to form the same sort of structure again, and then it can repeat its function and again in the body. Now, another thing I learned about flavonoids is that they can actually be particularly estrogenic. And I've talked about estrogenics before on this channel with things like BPA and phthalates and other stuff like that. And estrogenics aren't exactly the best thing for you. But there are plenty of different flavonoids out there, and only some have a reasonable binding affinity to estrogen receptors that they can actually cause some kind of damage. The main 2 culprits for these estrogenic sort of properties are soy and flaxseed, and these chemicals and these food groups, soy and flaxseed, contain no comparative advantage over other foods. Flaxseed is essentially just chia seeds, but flaxseed has a bunch of phytoestrogens and hormones, so it's better off that you eat chia seeds and get the exact nutritional profile than flaxseeds and have a slightly lower testosterone rate and a disrupted hormone system. But all in all, these flavonoids are good for you and disarm free radicals and stop you from aging. That is a really good net positive benefit. And as much as you could go ultra healthy and get rid of all of these stuff, that wouldn't be beneficial for you, because you'd be sacrificing the antioxidant properties. And is that necessarily worth it? Who knows? There are other antioxidants out there, I suppose, that aren't flavonoids. But flavonoids are an easy source that you can get. From real foods that's basically inside of every single whole food that you actually eat on a daily basis. There are drawbacks to everything, and I'm sure that there are plenty of other foods that you eat that you consider healthy that contain some kind of drawback and negative. I think just because in the sort of whole masculinity space, I suppose, there's a testosterone craze. You must get your testosterone as high as you possibly can, and that's no bad thing, I suppose, but you can often be a bit blindsided by making sure that you get rid of everything that's going to decrease it, and you ignore the potential benefits of those things that will only decrease it slightly, and so you're kind of making the wrong decision. I mean, I can't exactly judge the decision objectively, it is a decision after all, but is that necessarily the best thing for your overall health, even if it does slightly increase your testosterone? But with that, I recommend subscribing for more content like this, and have a good day.